In this video, I'm going to go over how do you go from an acceleration graph, so acceleration and time, and then switch over back into a velocity time graph, and then finally a position time graph. So how do you do that? Now, I have done now several videos on these particular topics. One was kind of starting from your position time graph and then going in reverse. So, well, going in kind of the direction from position to velocity to acceleration. I'll put up a link up above there. Okay, it was hopefully very informative, and it took on a pretty challenging example as well. Now, I've also done the case where you have been given a velocity, so instantaneous velocity graph and time, and then going back into your position time graph and then going back into acceleration time graph. I'll put up a link up above there for that. Well, the last component is an example where you're starting from acceleration. So now how do you go back into velocity and then back into position? Well, so if you are dealing with these particular graphs, we're assuming here that we have uniform acceleration. So that particular acceleration is either going to be positive, it's going to be negative, right? So those are the two if it's a uniform acceleration, or possibly, you know, the acceleration is just simply zero. And in that case, we just have constant velocity, or we possibly have zero velocity. So those are the only cases that you study in kinematics in the beginning, kind of in introductory physics course. So all of these three are actually captured here. So notice we have a positive, we have a negative acceleration. They're all constant, and then we have zero acceleration in that particular order. So our goal is to be able to take these right here and be able to go back in reverse. Now, so how do you do that? Well, it turns out that we are actually kind of looking at the area under the graph, right? So what is the area under the graph? So for instance, if you were dealing with this particular case, what you would do is you would just take the area under this graph, and now it's going to be very easy because it's a rectangle. And that area under the graph just simply means what's the acceleration times what's the time, and then it will bring you the change in velocity. Now, it does give you the change in velocity. It doesn't actually give you the exact velocities. So you do have to make an assumption that you know what your initial velocity was. Now, if your initial velocity was zero, then the change in velocity is going to be what it is. Now, it's not always zero, but it will be dependent on whatever your teachers give you. Now, in this example, as you can see here, so from this acceleration going to velocity graph, I am actually given the assumption that my velocity, now my initial velocity right there, or I just simply wrote V and a little zero, just which means for, okay, the initial or time, okay, at zero, you know, what happens, and here it is starting at zero. So we can do that, right? We can find the areas under the actual graph. Now, once we have this, you know, once you are dealing with this graph, so although I have done a full out graph, and that was kind of the second link that I provided you, so you can certainly go from there and then back into position. But that path, okay, so from here going back into your position is also another calculation of area under the curve. And it gives you the displacement, right? So it gives you the total displacement that you have. And again, you're going to have to know what your initial position was if you really want to be able to figure out what that graph is. Because going from here to here and then going from here to here, you're just finding, okay, the change in velocity, okay, or the change in position. So in this case, change in position is displacement. But you don't necessarily know where you're starting from, right? Unless they give that to you. So in this case, they do provide us kind of the initial starting points for our graphs. So that's my kind of starting point at time is equal to zero. Okay, so it's zero. But notice that this is kind of not very common in introductory physics. It's typically assumed that you're always going to be starting from 0, right? Your initial position is 0. Now 0 meaning with respect to your reference. So in this case, you know, you're going east here, which is positive. Okay, in that case, so east would have been this way. And you're starting basically right at 0 over there. So we're not going to be starting at 0. We're actually going to be starting at minus 200 meters. Notice right here, east. So it's kind of like saying we're starting at 200 meters west, right? So that's where we are. If we were drawing this out, you know, here's our reference at 0, you know, we would have been at minus 200, or really at 200 meters west in terms of our position. So let's see, let's jump into this because I think it's worthwhile taking a look at this. So let's tackle it one by one. So the first piece that I'm going to take is I'm going to take this actually, so the area right here, so that I have. So I'm going to have to take this particular rectangle and find out what the area under the curve is. And again, that will give me what the change in velocity was right there. So calculating this out, as I have this, okay, currently, so notice it's not very difficult. So the actual change, the area under the curve, so it's going for 20 seconds and it's 1 meters per second squared, okay, so in here. So that's what we have right there. That's 1 multiplied by 20. And notice the units, it's meters per second squared times seconds, so indeed it's going to be meters per second. So this is just going to be 20 right there. So 20 meters per second in terms of the change. Now, because we're starting from 0, so notice right here, we're starting from 0 right there. So if I was kind of drawing this out for myself, right? So I like to draw this all out before I start plotting it, when especially when I'm dealing with area, because I want to see, you know, how I should scale that particular velocity graph right here. So if this is kind of east, now I'm talking about velocity. So it looks like I started from 0. So let's say, you know, let's assume 0 was over here. And then this change, what this would mean is that I would shift in this particular direction. And I have shifted it 20 meters per second. So that's going to be the first thing that I have. Now, the other part that I should know is this is a positive acceleration. And remember that when you're going from velocity to acceleration, when it's positive, so it's constant, that just means, okay, that your graph actually is going to be looking like this, right? It has a positive slope, and it's going to go to positive slope, and it's going to peak at 20 meters per second there, and it's going to start from 0, right? So that's what we have, because the slope is actually the acceleration. Now, the second component is very easy, because right here, what this is telling us, that the change, okay, in velocity is 0, right? So there is no acceleration, so it looks like we're going to be going at basically just staying at the same exact, okay, spot, okay? In terms of, now spot, be careful, it's not position, but velocity. So velocity is not going to change, it's just going to stay there, okay, at 20 for that particular duration. So it's just going to be basically staying at 20 meters per second. And what does that mean? That would mean that it's just basically a flat line at 20 meters per second. Flat line, the slope of a flat line is 0, and indeed that's what we see, okay, on this particular graph. The last component, so that's this particular component. So here we have another kind of rectangle. Okay, so within here, so what is that going to be for us? Well, so this particular change again in velocity, okay, is going to be, so we need area right here. So that's this particular area. Now it isn't going to be negative. So notice it's -2 times 10 seconds. And this looks like it's minus 20, you know, meters per second, right? So what this is telling me that I'm actually going to go, so from this point, I'm going to go back. Okay, so right there. And basically end up at 0 again. So this is going to be, you know, -20 that I'm going to be shifting away. So it looks like I go to 20, I stay there at 20, and then I go back. And notice it's a negative acceleration, constant acceleration, okay, that I am having. Now, what does that mean in terms of my graph? Well, in terms of my graph, what that would mean is that it would look like, and it would have a slope, which is a negative slope like this. So I need these components. So now I know that my maximum is 20, so now it's very easy for me to label these. Okay, so I kind of label it now, so I can go 10, 20, 30. I actually won't need the negative ones because it looks like it's always positive or 0. So here you go. Okay, so we're going to get started. We're starting from 0 right here. We're going to be going up to 20. So this is going to be going up to 20. Okay, and it has a positive slope. And notice if you calculate the slope there, which would have been rise, okay, over the run. So notice it's 20 meters per second over 20 seconds, which indeed is equal to 1, which is exactly what we saw here on the acceleration. The next component, okay, that we have in here, well, we have a 0 acceleration here. So that means we're not going to be moving anywhere. We're going to be staying exactly. Now this is all the way up to 50. So all the way up to 50, we're just staying flat. So we're just flat lining here on our velocity. So it's just staying at 20 meters per second, right? So that's coming in from that acceleration of 0. And that last piece, notice that our change is minus 20. So if we're at 20 and we go to minus 20, right? So our initial starting point is 20. Minus 20 is going to take us to 0. And this is how our graph would look like. So basically, we're going down. Notice the slope, so it's negative. And indeed, so we're going down, we're falling, okay? And then we're going and running for 10 seconds. So it's negative 20 over 10, which is negative 2 as our acceleration, which is exactly what we saw over here. So there you have it. So that is how you can go from an acceleration back into a velocity graph. Right, so now we have our velocity graph, and now if you wanted to double check, you can of course go in this direction just by looking at slopes to make sure that everything is okay. So now, what if we're going to go in the next direction? So what if we're going to be going into the position? So well, let's do that as well, just to kind of kick this off. And again, so what I'm going to do here for myself is I'm going to just draw out, okay, so this is, east, okay, direction, okay, so let's imagine that this is going to be 0. So this is going to be my position, right? So in terms of displacements, okay, that I have, okay, this is what I'm going to be looking at. So before I start drawing it out, okay, these particular position, I'm going to kind of begin from the fact that I'm assuming that I am starting off at time t equals to 0 at minus 200 meters. Now, I don't know exactly where that is, but let's just, say that minus 200 is here. Okay, so that's going to be right there. That's my position, my initial position. And now, okay, as I go from here to here, I have to find the areas under the curve. So I'm going to have 3 pieces. I'm going to have one piece over here, second piece over here, and third piece over here. Why? Well, because I have a straight line. So here's my little triangle in terms of my displacement. So I can calculate what that is. Well, so triangle, so it's 1/2. Notice the height, okay, which is 20, okay, times the actual base, which is going to be also 20, right? So I can find out exactly what this is. So this is going to be 200. Okay, so this is 200. Now, what does that mean? What that is telling me is that if I'm going to start from minus 200 and I'm going to go 200, notice the displacement, it's positive. So I'm going to be going back to the reference point of 0. If my initial point of starting, so my initial position was 0, then I would have just gone from 0 to 200. So that's the only change. But now I'm told that I'm starting at minus 200. So that is my first little triangle, my area under the curve. Now, notice that it is, positive slope there now. So what does that actually mean if I'm going to go back from velocity back into displacement? So I am speeding up here, right? So I'm going up, I'm starting from 0, and I'm kind of speeding up here all the way along to 20. So what does that mean for my position? Because these are instantaneous velocities, right? So all of these points, they end off there at 20. What this means is, okay, that I'm kind of going and speeding up in this direction. So this is what I have, and these would have been my instantaneous velocities that I have in there. So that is how my graph is going to look like for the first piece. So I'm going to just kind of draw it out for myself, it's going to look like this if it was a position time graph. And the starting point, so this point right there, is going to be minus 200, and then the ending point over here is going to be 0, right? Because it's a displacement of 200. So from minus 200 to 0. That's what I have. Now, my next piece, so which is this piece right here, okay? So this is, you know, a nice big kind of a triangle that I have in there. So for this particular piece, so what I have is, well, an actual, rectangle. So this is going to be 20 multiplied by, and I guess it's going from 20 to 50, so that's 30. Okay, so this is 600 meters. Now notice it's positive. So what does that mean? So that means that I'm going to be moving along here, you know, 600 meters, okay, whatever length that might be, okay, and I'm going to end up over here at 600 meters. So that is my actual displacement, and I'm starting from 0 over here. So I'm ending up at 600, so position 600 right there. Now, and this is a flat line for velocity. Now, what does a flat line mean for velocity? It means that your velocity is constant. There is no acceleration. And if you were going back into position, right, so how did that look like? Well, so that particular case, okay, so how it looked like, okay, this was just an actual slope, right? So this was just a straight line, and it would have a rise, okay, and a run. Okay, so in that particular case, it would be equal to 20. So your slope would have been 20 over that duration. So that is what we would have over here. Now, my third piece, so this is now my little triangle here, right there. So this is what I would have there. So 1/2, and notice this is going to be 20 multiplied by, this is only 10 seconds. So it's going to be 100. But it's still moving, so notice it's still positive, so it's still kind of going along. So this is going to end up at 700 meters over here. And that's what it looks like. So it's still moving, but notice that your speed, right, your instantaneous velocities, notice that what's happening to them. Okay, they're getting less and less and less and less. That means you're slowing down in this case, right? You're slowing down. You're basically slowing down all the way up to a 0. So you're still moving in the east direction, but now your speed is coming up. It's like almost like you're thinking about coming to a stop. You know, maybe there's a red light. So you're still moving, in this case east, but you're slowing down. And now how does a slowing down look like on a position time graph, right? So this particular case, so how would that look like in here? So this is just a reminder. So this is going to look something like that, right? Where it's kind of slowing down. And again, notice because here's your highest instantaneous velocity. Then, okay, you can notice that the slope keeps decreasing until eventually it comes to 0. So now we're going to take these three pieces and connect them together for here. Now, I also love doing this for myself before I draw this, so that I can see how I can scale. Notice that I'm going to go all the way up to 700. If you're going to start putting the numbers over here before you start doing this, then you might not scale it properly. So this is just a hint for you as a student. You know, I encourage you just draw it out in terms of vectors like this. You know, see where you're starting, see where you're going, you know, how far do you end up. So notice minus 200. And then, you know, it goes up to 700. So I'm not going to have a lot of space here. So I think I'm going to go by, you know, 200 meters every time. So this is going to be 200, 400, 600. This is 800. And this is minus 200. I guess I don't need the other one because it's minus 200 is max. All right. So our starting point, so this is really cool, is that we're starting from here. We're not starting from 0. If they don't give you these, again, please remember, if your teachers don't give you a starting point, just assume it's always starting from 0, from a reference of 0. Otherwise, if they give it to you, sometimes they're mean like me, okay? And they'll give you that just to really test your understanding, okay, of how you're going to be drawing these out. Okay, so coming back to here, so this is for 20 seconds. So it's not very exciting, but, you know, this kind of goes in, kind of looks like this. Okay, and it stops at 0. And notice, how do I know that? You know, well, because it was a displacement of 200 over here, right? So this was my first piece, right? So that's that first piece area under the curve. Now from here, right, it just keeps being constant. So this is all the way up to 50, and it ends up at 600, right? So this is going to be ending up at 600, so that's going to be somewhere right there. So this kind of continues on, okay, and kind of looks like this, which makes sense, right? So as you're going through, and again, to double check for yourself, keep in mind, rise over the run. Well, the rise, okay, going in there goes from 0 to 600, right? The run itself is 30, and notice 600 divided by 30 is indeed 20 meters per second, which is exactly what we got on this piece right there. So that's how you can check. And then the last piece, again, so that's not very difficult, so we're still kind of moving along, and we've moved to 700. So, well, this in this case is going to be kind of stuck there in the middle between 600 and that. And this kind of continues on and then levels off. Now, it's not the greatest of things, but your slope here should be 0, okay? And then your slope over there should be aligned exactly, okay, with that starting position. And there you have it. So now you have a nice little graph in transition all the way from acceleration back to velocity, back to a position time graph. Okay. Thank you for watching. I hope that you find this useful, okay? Hopefully you're subscribed, and we'll see you in a future video. Bye, everybody.